Welcome to Ask and Learn.
Hello everyone. In this question we will learn about some basic concepts of the chemical reaction. Right? The question is we have to repeat the problems from 15 to 29 by replacing the dry air with the moist air, and it enters the combustion chamber at 25 degrees centigrade, 1 atmospheric pressure and 85% relative humidity, right? So as we know that general form of the chemical reaction in this case would be 0.65 CH4 plus 0.08 hydrogen plus 0.18 nitrogen plus 0.03 oxygen, zero point 0.06 carbon dioxide, right? And this will give the product as BCO2 plus CH2O plus the nitrogen. Now, the analysis of the components gives the values of the coefficient, that is A equals to 1.31, B equals to 0.71, C equals to 1.38, and D equals to 5.1056. So after introducing these coefficients, we can rewrite the chemical reaction. Next step is to find the partial pressure of the moisture, right? So the partial pressure of the moisture is obtained from the relative humidity, that is P air is equals to phi multiplied by the saturation pressure at 25 degrees centigrade. So that would be equal to zero point 0.8 multiplied by 3.1698 kilopascal. So the partial pressure of the moisture comes out to be 2.694 kilopascal. The amount of the moisture is determined from the relation which uses the pressure of the moisture and the pressure of the mixture, right? So the relation would be N air is equals to the partial pressure of air divided by the total pressure multiplied by the total number of moles. So this would be equal to 2.694 divided by 101.325 multiplied by 4.76 A. The value of A is 1.31 plus N air. So when we solve this equation, we can find the value of N air, that comes out to be 0.168 kilomoles. Now, with the help of this, we can rewrite the chemical reaction, and we can find the value of the air fuel ratio. The air fuel ratio is now determined from the mole numbers of dry air and the moisture content along with the mole numbers of the natural gas components. So the air fuel ratio would be equal to 29 into 1.31, that is the mole number of air, into 4.76 plus 0.168 multiplied by 18 mole numbers of H2O divided by the mole number of CH4, that is 0.65 into 16, the mole number of hydrogen, that is 0.08 into 2, the mole number of nitrogen, that is 0.18 multiplied by 28, the mole numbers of oxygen, that is 0.03 multiplied by 32, and the mole numbers of CO2, that is 0.06 multiplied by 44. When we solve this, we get the air fuel ratio as 9.58 kg of air per kg of fuel, right?